So we begin our revision with the paper of December 2012. The paper of December 2012. And in this paper, we have question number 1A. We are told to state 4 characteristics of a good measure of dispersion. Now, those ones, in the interest of time, I would suggest that you look at your notes because we covered them in class. Explain the meaning of the following terms as used in set theory, Venn diagram, complement of a set, union of a set. I also suggest that you look at them, you have them in your notes. Part C of that question, it is already solved in class, so you can check the notes. That brings us to question number 2, which says that Shoetech Limited, manufacturer of stylish shoes, estimates that at full-scale production, it would sell between 2,000 and 3,000 pairs of shoes. The total monthly revenue in thousands of shillings over this range is represented by TR is equals to 3x squared plus 7x. The firm estimates that the marginal cost in thousands of shillings should be presented by the function that, and the fixed cost will be that per month, where X is the monthly output in thousands of pairs of shoes. You are required to derive the average costs and the average revenue functions for the firm. Now, in answering that question, we will begin by saying that average, we are looking for the average of anything. Average is given as total, you divide by the units. You divide by the units. Average is total, you divide by the units. We are looking at the paper of December. Paper of December 2022, that's what you have said. December 2022. Now I'm handling question 2A. That's where we are, question 2A. Now I'm saying for you to get the average, you require the total and then you divide by the units. So we require the total function for the revenue, for the total revenue is given as 3x squared plus 7x. So when they ask us for the average revenue, it will be 3x squared plus 7x. Now the whole of this we divide by x, which is the number of units. And in so doing, this becomes 3x plus 7. That is the average revenue. Then for the costs, when they give us marginal cost as 5x squared minus 3x minus 2, then the total cost should be arrived at by integrating this 5x squared minus 3x minus 2 with respect to x. We integrate that with respect to x. So this one, as you know, we will say 5x squared, you add back 1, then you divide by the new power, 2 plus 1. Then you minus 3x, which is currently raised to power 1. You add back 1, you divide by the new power, 1 plus 1. Minus 2x, which is currently raised to power 0. You add back 1, divide by the new power, 0 plus 1. Then you add the constant of integration C. You add the constant of integration C. And when you add the constant of integration C, the total cost here then settles as 5x cubed. 5x cubed, you divide by 3. 5x cubed, you divide by 3. 5x cubed, you divide by 3, minus 1.5 x squared minus 2x plus c. And c, we say it is always the fixed cost. Because the equation is in thousands, then we will say plus 1. Because the equation is in thousands. The equation is in thousands. So the average cost would then be 5x cubed out of 3 minus 1.5x squared minus 2x plus 1. All this you divide by x. All that you divide by x, which is the number of units. You divide by x, which is the number of units. So it settles as average cost. This one becomes 5x squared out of 3 minus 1.5x minus 2 plus 1 out of x. Plus 1 out of x. When you divide this by x, this is what you get. Now, if that is what you get, the examiner had asked us to derive the average cost and the average revenue functions. So we have done that. The next thing is calculate the profit maximizing output. So we will need to say that total profit should be equal to total revenue you minus total cost. Total revenue you minus total cost. So my total revenue was 3x squared plus 7x. Now this one you minus the total cost, which is the 5x cubed out of 3 minus 1.5x squared minus 2x plus 1. So that's how we base our pi, which is the profit. Pi, which is the profit, it will open as 3x squared plus 7x minus 5x cubed out of 3 plus 1.5x squared plus 2x minus 1. Minus 1. So, putting the like terms together, we get that pi, this square here to join this one here. And when they join, we are left with 4.5 x squared. 4.5 x squared. Then this 7 here to join these two here. And in so doing, we talk of plus 9x. Plus 9x. Then this cube here is on its own minus 5x cubed out of 3. And then this one is on its own minus 1. So that is the profit function. That is the profit function. So if that is the profit function, that is the profit function, we proceed and say for maximum profits, if you want to earn maximum profit, you differentiate with respect to x. This function here, 4.5x squared plus 9x minus 5x cubed out of 3 minus 1, and you say it is equal to 0. You differentiate that with respect to x, and you tell us it is equal to 0. So in doing that, this to multiply here, we get 9x. Then this one to minus 9. Then these 3 to come and cancel here, you have to achieve a minus 5x squared. That one disappears, and then we are left with 0. We are left with 0. So using quadratic formula, using quadratic formula, which we know so well, inasemanga x is equals to minus b plus or minus b squared minus 4ac. To get the square root, you divide by 2a. You divide by 2a. You are going to get, you're going to get our b is this one, so it's minus 9 plus or minus 9 squared minus 4 times a. Our a is this one, negative 5. So it's negative 5 times c. C is this one, 9. This one, you get the square root. Then you divide all this by 2 times a. So 2 times minus 5. So we get minus 9 plus or minus. Now give me what is here on the square root side. Give me what is there. Waiting for your answer. You say 9 squared plus 4 times 5 times 9. Square root. I'm getting 16.16. 16.16. So if I get 16.16, 16.16, then this is minus 9 plus 16.16. You divide by minus 10, all minus 9 minus 16.16. You divide by minus 10. So if I say minus 9 plus 16.16 equals, divide by minus 10, I'm getting negative 0.716. All, if I go back there and say minus 9 minus 16.16 equals, you divide by minus 10, getting 2.516. 2.516. And as we have been saying, you cannot have negative units. So you just have the positive ones. So this then settles as 2.516 units. 2.516 units. So the examiner had asked, calculate the profit maximizing output. So that one we have calculated. Number 3, calculate the price charged upon maximizing profit and how much each of the shoes would cost. So the price at this point, you will have to come back where we had our costs. We'll go back to where we had our costs and our prices. And when we come here, we are going to say this. That price price is the same thing as total revenue. Total revenue, you divide by the units. In other words, price is the same thing as what we called the average revenue. So this one we had gotten it as 3x plus 7. Therefore, this becomes 3 times 2.516 plus 7. And therefore, we are going to say that one shoe inastahili kuuzwa that money. That is this times 3 plus 7. 14.548. 14.548. That is the match that we should get. I have cost per shoe, it is the average cost. Remember, the word average means 1. As you can see, we are dividing. So we can bring this so that we are able to quickly connect. That is 5x squared you divide by 3. Minus 1.5x minus 2 plus 1 out of x. So when we proceed with this working, you will be able to say 5 multiplied by 2.516, which is squared, then is divided by 3, minus 1.5 multiplied by 2.516, minus 2 plus 1, which is divided by 2.516. And you tell us one shoe is going to cost how much? One shoe is going to cost how much? And according to my workings, I'm getting 5.17. 5.17. So I believe that we are okay with that. And if that is true, let us now go. But next of the question, which is saying that an examination was administered to a group of students and the results were as summarized below. Those who passed with distinction, those who passed with credit, and those who failed. A candidate fails the examination if he or she obtains less than 40% in the examination. In order to pass with distinction, the candidate must obtain at least 75% in the examination. Now calculate the mean and the standard deviation of the distribution of marks, assuming that the marks scored are normally distributed. So that is a case of normal probability distribution. And in this case of normal probability distribution, we are going to have something like this. Now, in this case, we have the mean here, x bar, and this one we do not know. It's one of the things we are being told to compute. Standard deviation is here, which again we do not know. It's one of the things we are told to compute. But we are told the students are divided into 3. There are those who got a credit here. There are those who got a distinction. And there are those who failed. So those who failed, we are told the percentage of those who failed is 0.3. And then we have those who passed with the credit. Those who got the credit, they are 0.6. And those who passed with the distinction, they are 0.1. And for you to fail, you must have scored less than. So our x1 here is 40. And for you to get a distinction, our x2 here is 75. 75. So in this case, we will begin by saying that Z, maybe we can begin with Z1. Z1 is supposed to be given as X1 minus X bar, you divide by standard deviation. Divide by standard deviation. So in this equation, we do not know X bar, and we also do not know standard deviation. So we can say from the tables, Z1 is equals to Z1 is equals to. So go to the tables, we go to the normal tables. Now, as you know, from here, the center, mpaka huku, this must be 0.5. So hii ni kumaanisha hii ka section haka ni 0.2 na haka kengine ni 0.4. So that when you add now this plus this, they give you 0.6. And then when you add this 0.2 plus this 0.3, they give you 0.5. So what we shall do ni kuenda kwa tables tusome hii 0.2. We look for 0.2 inside the tables. And when you look at your tables for 0.2, I think I'm getting 0.201, which is the 0.53. And because this Z1 is on the X1 is on the lower side, it will be negative. So this is negative 0.53. Negative 0.53. So if it's negative 0.53, I proceed here and I say minus 0.53. Minus 0.53 is equal to X1, which is 40, minus X bar, which I do not know. You will divide by the standard deviation, which I also do not know. So this becomes negative 0.53 standard deviation is equals to 40 minus X bar. So if I put right terms together, I can be left with minus 0.53 standard deviation plus X bar should be equal to 40. And this one I call it equation number 1. That one I call it equation number 1. That one, I call it question number 1. Sasa, let's do the same now with x2. We come here and say z2 should be given as x2 minus x bar. You divide by standard deviation again. So from the tables, Z2 sasa tutaenda kwa table tuende kutafuta hii 0.4. Hii ndio tutaenda kutafuta huko ndani 0.4. So when we get there 0.4 I can take kuna hiyo 3997 na 15 4015. So I want to take the nearest, which is now 1.28. 1.28, and it's positive. It's positive 1.28. It's positive because this x2 is on the upper side. Is on the upper side. So I'm going to rub here instead of moving my camera. So this one, then going to say 1.28. 1.28 is equals to x2, which is 75, minus x bar, which I do not know, you divide by standard deviation. So this becomes 1.28 standard deviation is equals to 75 minus x bar. So putting items together, 1.28 standard deviation plus x bar is equals to 75. So this one, I call it question number 2. So now I have equation number 2. I have equation number 2. So when I have equation number 2, solving the simultaneous equations. Solving the equations or the simultaneous equations. Simultaneous equations. Solving the simultaneous equations. I'm going to have minus 0.53 standard deviation plus x bar being equal to 40, and then 1.28 standard deviation plus x bar is equals to 75. So as you know, we are going to say this one we subtract. This one we subtract. And when you say you subtract, you will get -1.81, negative 1.81 standard deviation. This one will go. And here you are left with minus 35. And this means the standard deviation now should be 19.337. 19.337, that is the standard deviation. And when I come here to question number 1, we say minus 0.53 multiplied by 19.337 plus x bar is equal to 40. From there, I should be able to solve comfortably and be able to say that x bar will be equal to what? So it will be 0.53 times 19.337 plus 40. So I'm getting 50.24.25. So that is the mean. That is the mean of that class, of that exam. So I believe we are okay. So let us go to question number 3. Question number 3 inasema, distinguish between the following terms as used in probability. 1, conditional probability and marginal probability. Number 2, discrete probability distribution and continuous probability distributions. Roman 3 is not there. Don't know what it was. Now, these things are in your notes. And once again, just like I said with question 1, A and B, I suggest that you look at your notes because I already have given you these notes so that we can reserve the time for the computations. And I want you to take note that these theory questions are taking a lot of marks. You can see question 1, it had a whole 10 marks in theory. Question 1, it is 10 marks. You can see now, this question 3, it is coming now again with another 8 marks. So those are already 18 marks. So 18 marks coming from theory. So that is a significant number of marks. Therefore, make sure you take time and get the answers because they are there in your notes. Please do not ignore that. So part B is saying the banking or the banking industry in a given country is controlled by 3 banks: Faida Bank, Akiba Bank, and Ahadi Bank. Is at that 1st of December 2020, Faida Bank controlled 30% of the market share. Akiba Bank controlled 50% of the market share, and Ahadi controlled 20% of the market share. A survey was conducted on the market shares of the 3 banks as at that 1st of December and revealed the following. So we are given that. Now, I think we solved this question in class. Someone to tell me yes or no? Did we solve the question in class? Okay, you remain quiet, so I go by my guess, and I'm thinking we solved this question in class. So if that is true, then you can refer your notes on Markov analysis for what we did there. So we got question number 4A. The production manager of MakeTex Limited, a manufacturer of machines, is investigating a claim by customers about machine A and machine B that it manufactures. The claim is that machine A has a longer use than machine B. A sample of 60 machine A's taken from the market reveals that the machine has a mean useful life of 28,000 hours with a standard deviation of 900 hours. A sample of 80 machine B's has a mean useful life of 30,000 hours with a standard deviation of 1,000 hours. Required: advise the production manager of MakeTex Limited if there is a significant difference in the useful lives of the machines, and we are told to use a significance level of 5%. So when we covered these things, I told you that there are two types of questions in this area. There is the question of hypothesis testing and the question of confidence interval. And I told you, anytime you see the word significant, it is about the hypothesis testing. So this question is on hypothesis testing. And I also told you that what we need to do is to check whether the population is known. And we check whether population is known by checking whether we know the standard deviation of the population. So in this question, they have already given us the standard deviation of the samples, but not for the population. So in that case, then, we will say this is a case of unknown population. Is a case of unknown population. It's a case of unknown population. And in the case of unknown population, the next thing I told you need to find out is how many samples that are involved. And you can see here, they took 2 samples. So it is 2 samples. It is a case of 2 samples. And if it's a case of 2 samples, we need then to know what are we comparing. The question is saying we get whether there is a significant difference in the useful lives. And as you can see in the literature there, the useful life is being measured in terms of the mean. So we are getting to look at difference in means. Difference in means. Or means difference. So that is how we are going to approach it. So it's a question that has a known population. It has 2 samples, and we are looking at the difference in means. So we said that the first step is always to come up with the hypothesis. With the hypothesis, that's the first step. And in the hypothesis, I told you, in the null, you say that the mean of the first sample is equal to the mean of the second. The mean of the first is equal to the mean of the second. So when you look at this question, the mean of sample A was 28,000. And the mean of sample B, it is 30,000. It's 30,000. So you say they are equal. Then in the alternative, 8A, you now compare the size. You can see this one is smaller. So we will say x1 is less than x bar 2. That is 28,000 is less than 30,000. 28,000 is less than 30,000. The next thing is called significance level. Significance level. Now, significance level, it is alpha. The examiner has advised us that we use 5%. So it is 0.05. Significance level. The next thing is what we call test statistic. Test statistic. Now, test statistic, we use T, which is always given as x bar 1 minus x bar 2. X bar 1 minus x bar 2. Now, this one, we say it should be divided by the square root of n1 minus 1 plus n2 minus, sorry. The standard deviation 1 squared plus n2 minus 1 s2 squared. Now this one, n1 plus n2 minus 2 times 1 out of n1 plus 1 out of n2. And the whole of this, the whole of this get the square root. The whole of that, you get the square root of it. So that our T calculated will be 28,000 minus 30,000. You divide this by the square root. By the square root of n1. In sample A, we had gotten 60. So it is 60 minus 1. Multiplied by standard deviation. The standard deviation there is 900. You square it. Plus we wingine tulichukua 80. So 80 minus 1. You multiply by the standard deviation 1000 squared. Now the whole of this, we're dividing by 60 plus 80 minus 2. Then you multiply by 1 out of 60 plus 1 out of 80. So you proceed now and give me the answer. Get the answer. Yeah, 12.22. Good. Negative. It's negative 12.22. So that is the answer. Now from there, we go to the next step. We go to the next step, which is called the division rule. We go to the next step, which is called the decision rule. And the decision rule, this decision rule, remember, it is what we call the one tail. Is one tail because we say here is less than. And the degrees of freedom will be, 60 plus 8 minus 2. 60 plus 8 minus 2. That is 138. The degrees of freedom will be 138. So Sasa, when you design it like this, you will come here on the negative here, minus T critical. This side here, you will tell us to reject. Here, we will reject null hypothesis. And here, we shall accept null hypothesis. Shall reject and accept. So you now go to the T tables, the T tables. And when you go to the T tables, you will go to the one tail confidence. The one tail confidence level at 95%, where we have 95%. Then uteremuke where we have 138. And because you can see our table, the farthest has gone is 30. I told you if you get a figure that is more than your table, you go for the highest value in the table. So the highest value in the table is 30, and at 95, we have 1.6973. So this is minus 1.6973. Minus 1.6. So with that, the next thing is now called conclusion. Conclusion. So conclusion is where you compare this one that we have gotten, they calculated with this one. So we are going to say reject null hypothesis. We reject null hypothesis since T calculated is less than T critical. T calculated is less than T critical. That is minus 12.22 is less than minus 1.6973. Is less than. So if it is less than, what is the meaning of this? What is the meaning? So the meaning is written in the words of the examiner. The examiner had asked us to tell, the examiner had asked us to tell whether there is a significant difference in the useful lives of the machines. Now that we have rejected the null, which was saying null ilikuwa inasema zinafanana. If you look at where we began, null was saying they are equal. So now that we have rejected, then we are saying, meaning there is a significant difference. Meaning there is a significant difference. Significant difference in the, there is a significant difference in the useful lives, the useful lives of the machines. The useful lives of the machines. So that is how you are supposed to handle that question. So I believe we are through with that. So we can go to the next question. So part B nasema the following data relate to the number of computers sold each day over the last 240 working days by a leading computer firm. So we are given that data and then we are told get the model number of computers sold, the quartile deviation, and the quartile coefficient of skewness. I told you when you're dealing with these kind of questions, the first thing is always to write the formula. So the mode of group data we know so well is always given as L plus B1 out of B1 plus B2 you multiply by W. Multiplied by W, that is how we get the mode. And remember, D1 is the frequency of the model class minus F1, the frequency above, And B2 is given as the frequency, the mode of frequency, minus the frequency below F2. The next thing that they require is quartile deviation. Quartile deviation. Now, quartile deviation, we know so well, is given as Q3, Q minus Q1, the quartiles, you divide by 2. You divide by 2. Then what they are calling the quartile coefficient of skewness, quartile coefficient of skewness. Remember, I told you there are very many types of skewness. So this quartile skewness is usually given as Q3 plus Q1, U minus 2Q2, you divide by Q3 minus Q1. That's how it's given. That's how it's given. So what you can see is that there are a lot of quartiles. And remember that any quartile QK is given as L plus Kn, you divide by 4, minus the cumulative frequency above, you divide by the frequency of that class, you multiply by the width. Multiplied by the width. So when you have those formulas in place, it now becomes very easy to prepare the table. Becomes very easy to prepare the analysis table. Because you know what is it that you are looking for. So in our preparation, obviously we shall have the class, then we shall have the frequency, then according to this, we will need to get the cumulative frequency. The cumulative frequency. The cumulative frequency because of this. Yeah, I think those are the only 3 columns that we will require. Those are the 3 columns that we shall require. So if those are the 3 columns that we shall require, then that makes our work very easy. It's our work very easy. So we have the class of 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50. The frequencies are 12, 18, 35, 42, 50, 45, 30, and 8. Sasa, we can come here and say cumulative is 12. So 12 plus 18, that gives us 30. Then if you say 30 plus 35, that gives you 65. You add 42, you get 107. You add 50, you get 157. You add 45, you get 202. You add 30, you get 232. You add 8, you get 240. Those are the cumulative frequencies. So we can start computing these values. You can start computing these values. So if I just even start here, the model class is the class with the highest frequency. Is the class with the highest frequency. So the model class is the class with the highest frequency. So Katia is not the highest is this one. So it is 30 minus 35. That is the model class. And therefore, my D1 or my L is this one, 30. The lower class, the lower limit. B1 will be the frequency that is higher, this one, 50, minus the one that is above it, F1, 42. That gives us 8. Then B2 will be the model class frequency, 50, minus the frequency below it, 45. That gives us 5. So with that, I think I need now to get W. W, it is always this one, the higher limit minus the lower limit. So that is 5. The higher minus the lower, that is 5. That is our W. So with that, I am able to say that mode should be the lower limit, which is 30, plus D1, which is 8, divided by 8 plus 5, you multiply by 5. You multiply by 5. That is how we shall get the mode. So this is 8 divided by 13 times 5 plus 30. So this gives me that 3.08. That 3.08. Haya. Sasa hizi zingine we need to get the Qs. We need to get the Q1, Q2, Q3. If we are using this formula, first quartile, now computing first quartile, that is Q1. First quartile, Q1. According to this formula, I'm supposed to say 1 times n. N is 240. And then I divide by 4. I divide that by 4. So 240 divided by 4 is 60. So if I get that, it tells me that my model class, not model class, sorry, is the quartile class. We are now in quartiles. My quartile class, it is where you find this 60. So unakuja hapa kwa the cumulative and 60 is here for 65. So my quartile class is this one, 20 to 25. 20 to 25. Sasa, the lower limit of that class is 20. The lower limit is 20. The frequency of this class, is that 5. The cumulative frequency above that class, the cumulative frequency above is this one, 30. And the width of that class is 25 minus 20, which is 5. So sasa niko na kila kitu that I require. So I'll then come here and say Q1 should be L, which is 20, plus Kn out of 4, which is 60, minus the cumulative frequency, that is 30. You divide by the frequency of that class, which is 35. Then you multiply by the width, which is 5. And when you do so, you are able to tell me this is minus 30 divided by 35 times 5 plus 20. It is 24.29. 24.29. So that one is okay. Let's now compute the second quartile. The second quartile. Second quartile. Second quartile, that is Q3. Sorry, not Q3, Q2. Second quartile, that is Q2. Now, again, going by this formula here, we require to say 2n. That is 2 times 240. I divide by 4. That gives me 120. 2 times 240 divided by 4 is 120. Sasa unakimbia hapa natafuta 120. It is here for 157. So that means the quartile class is 30 to 35. 30 to 35. That is the quartile class. The lower limit is therefore 30. And the frequency of that class is this one, 50. The cumulative frequency above, this one, 107. And the width is this 35 minus 30, which is 5. 35 minus 30, you get 5. So quartile 2 will then be the lower limit, which is 30, plus Kn, which is 120, minus the Cn, 107. This one you divide by F, which is 50. Then you multiply by W, which is 5. So 120 minus 107 divided by 50 times 5 plus 30. I'm getting that 1.3. 1.3. Let us now compute the third quartile. The third quartile. Third quartile. Third quartile, which we call Q3. Third quartile, which we call Q3. It is again 3 times 240 to divide by 4. I think this should be 180. 3 times 240 you divide by 4. That should be 180. So the quartile class is after 180 here. So that is 35 to 40. 35 to 40. The lower limit is 35. The frequency of that class is here, 45. The cumulative frequency above, this one, 157. And the width is this one, 40 minus 35, which is still 5. So consequently, my Q3 should be the lower limit of 35 plus 180 minus 157 divided by the frequency of 45. You multiply by the width of 5. multiplied by the width of 5. So 180 minus 157 divided by 45 times 5 plus 35 is 37.56. So because I can see time is already over, the formulas we already have them. Na hizi Q's ndio tulikuwa tunataka. So just substitute and get the quartile deviation and get the coefficient of skewness. So we are going to call it a lesson at that point. We meet tomorrow to continue from there. Thank you.